Okay, so we want to talk about the sum of geometric sequence, because it's going to help me to derive the formula that I eventually want to talk about. So what does this sequence look like again? I have some number a, then a times r, a times r squared, a times r cubed, and so on. Let's suppose it goes all the way to a times r to the n minus 1. So this is the first n terms in my sequence. For example, 1, 3, 9, 27, 81, and so on. If I want to add these up, how do I do that without listing them all? Let's suppose someone comes in, they see this list, they want to know for some reason, what is the sum of the first 15 terms? I don't want to make the whole list, this grows pretty fast. What is the sum of the first 100 terms? I want a formula to skip over making the list and just plug it in and give me my answer. So I want to know, what is the sum? What is the formula for the sum of the first n terms in my sequence? And the reason I'm doing this is going to come out. We need this formula in 10 minutes or so. So here's how I'm going to do it. Let's call this sum S, and let's write A plus AR plus AR squared plus all the way to AR to the n minus 1. I'm adding them, and I'm trying to figure out a way to determine what S is, or a formula for S. This is how I'm going to do it. Next, I'm going to say R times S. Well, R times S, don't write this down yet, is A times R plus A times R squared, every one times R, plus A times R cubed, plus all the way, I'll have this one coming from the previous one, and I'll have this. So let's just shift these a little bit to line them up correctly. Line them up underneath the one that looks the same. This sequence starts with this guy, and then ends with this, because every time I multiply with an r, the exponent increases by 1. So when I multiply this first guy by r, this is what I have. R times every one of those terms. The first one was an A, so now it becomes R times A. This guy was AR, I'm multiplying it by R, so now I have AR squared, and so on and so on.
Okay, so then why are we adding the AR?
The last guy, as I'm going down this list, the last guy here was A times R to the n minus 1. If I multiply that by another r, I get A times r to the n. I've added the exponents.
So you just multiplied r to both sides of the equation?
I just multiplied r to everything at the top here, and this is what I get. Okay? This is my method. Oh, sorry.
Okay, wait, what was it? You just said
A times r to the n minus 1 was this last one.
Yeah.
I multiply that with another r, so I get A times r to the n.
Okay.
So this was the last term here. I multiplied it by r, so this is the last term in this new guy. Now what I'm going to do is I'm going to subtract these. Can I erase this now?
Yeah.
Now I want to find what is r times s minus s. So the second row minus the first row. Second row minus the first row. Well, these guys will cancel. This minus this minus this, each guy cancels. This minus this guy minus nothing. It doesn't have a guy up there to cancel. So I still have this a times r to the n. This is technically a 0. 0 minus a, so I'll just have minus a. Everything else cancels. Because they're very similar, except for the first and the last one. Now let's solve for s, that's my goal. Factor out an s. S times r minus 1 equals a times r to the n minus 1. I can factor out an s on the left and factor out an a on the right. So s is equal to a times r to the n minus 1 over r minus 1. There's my formula for the sum of the first n terms in the geometric sequence.
And we need to know how to derive.
No. You don't need to know how to derive the formula. I feel that it's one of those things that you're not going to see anywhere else, so I'm taking the opportunity to show you, but I'm not going to ask it in an exam. We just need the formula to use later on. All right, that's my formula. So put a box around it. I'm going to use it in a second. Now we want to talk about ordinary annuities. What is an annuity? Well, I'm looking at the simplest situation possible. I'm going to deposit some amount represented by R at the end of every period. So what we had before was I had an initial amount of money, P. I put it in the bank. I let it get compound interest, but I never add to that amount. The difference here is that every time I add a specific amount. For example, I'm trying to save for something. At the end of every month, I put $100 into my bank account. So I'm putting money in, and the compound interest is increasing the amount. That's what I'm going to look at here. So I'm receiving interest compounded, let's say, over the same period. Could be a year, could be a month, some period. Is everyone happy with what type of investment we're looking at? At the end of every period, I'm putting in my own money, same amount every time, and I receive interest compounded over that period as well. As we look at an example, it should be a little better. Let's look at the first example. Example 1 helps me, guides me through this a little bit. Example 2 and 3 are more common questions that I might see in the test. This one breaks it down in steps to guide me through what we're trying to develop here. An ordinary annuity has annual payments of $1,000, 4% interest per year. What is the future value? How much money do I have after 3 years? Example 1A. So let's say here at the end of year 1, how much money do I have? Well, I'm looking at this basic situation where I'm putting in money at the end of my period. So technically year 1, nothing happened. At the end of year 1, I put in my 1,000. And now things are going to start. So I just have 1,000 at the end of year 1. I didn't actually do anything yet. At the end of year 2, how much money do I have? What's my accumulated amount? Well, this $1,000 now sat in the bank or whatever for a year, so it got interest of 4%, so it increases by 4%. It was sitting there for a year. and my period is a year as well. Then at the end, I'm putting in another 1,000. Oh, whatever. Running out of space. I'm putting in another 1,000. That's how I'm investing. My previous 1,000 got interest, and I'm putting in another one. How much money do I have? You have to get out those calculators today. Good practice. How much money do I have at the end of year 2?
Why are you using 1,000?
The example says annual payments of 1,000. Oh, sorry. So I'm investing $1,000 every year, and I get 4% interest. What's my amount here? 2040. What do I do, or what do I have at the end of year 3? Well, now this 2040 sat for a year, so I'm getting 4% interest on that, and I'm adding my own 1,000. How much do I have? $3,121. 60. Let's do one more to see the pattern as clearly as we can. Even though they don't ask for it, let's do another year. Now this $3,121.60 sits for a year, and I get 4% interest on that, and I add my own 1,000. What do I have? And I'll tell you what I have. I have 4246464. 4246.464. And if I want to calculate another year, don't round this and then use that. Keep it as accurate as possible. But the point is, I can keep going. What if I want to know how much money I have after 20 years? It's just not practical. It's just too much work. I want to notice a pattern to see how I can skip over everything and get to my target year. So at the end of 3 years, this is the amount that the question is looking for. This is how much money I have after 3 years. But my ultimate goal is to have a way of calculating it given any number of years. How do I calculate how much money I have at the end of any year? Let's do B first. Attempt to observe a pattern in the above calculation. So I'm going to do this again, but not calculate the actual amount. Leave it sort of in this expanded form and try to notice a pattern in the calculation. So this is B at the end of year 1. Well, A was simple, it was just 1,000. Nothing much to do there. At the end of year 2, how did I calculate my new amount? I took the previous amount and increased it by 4% and then added another 1,000. I want everyone to be sort of happy with what we're doing here. So I'm not going to calculate this, I'm going to leave it in this form to see the pattern. Everyone happy with how much money I have at the end of year 2? If we can understand these things now, Friday is going to be much easier. If we're not sure what's happening here, Friday is going to be a little bit worse. What happens after year 3? How do I calculate my new total amount? Well, I take this. This is how much money sat for a whole year. And I increase it by 4%. And then I add my own 1,000 for that year. I simplified this. Let's multiply this 1.04 into the bracket, the square bracket, to get 1,000 times 1.04 squared plus 1,000 times 1.04 plus 1,000. Yes?
Why in year two are you adding the 1,000?
That's how I'm investing. At the end of every period, I make my payment.
Oh,
So the previous end year amount set for a whole year, I get interest on that, and I make another payment. That's just the type of investment that we're looking at, the most basic case. Everyone happy with this? Any questions on this last line? So I'm not calculating a final number because I want to see how does the expression change from one year to the next. Let's do one more year, just to be absolutely sure. And yes, they're going to get longer and longer. I think I can manage one more year. Let's do it over here. So now my new amount at the end of year 4 is this whole previous amount squared 1,000 1.04. That gets increased by 4%, and I add another 1,000. What do I have? I have 1,000 times 1.04 cubed, because I multiply this guy into the bracket, multiplied with this middle one, 1.04 squared. 1,000 times 1.04 plus 1,000. And I can keep going, but you quickly see that I'm looking for a formula to do all this work for me. This is my rule for how I'm investing my money. At the end of every period, I add another 1,000. So this previous amount gets interest, and I add my own. Next year, this previous amount gets interest, and I add my own again. So it's all, I'm giving it money every time. Now, let's see, what is the pattern here? If I follow this to a general year end, what does it look like? How do I calculate? For any year number, how does the pattern continue?
And
What is the first guy here?
1,000 times 1.04 and
Is it an N?
wait, minus.
Well, look at the pattern. The year number, this is a 1. Year number 3, the highest is a 2. Year number 4, the highest is a 3. So year number n, the highest should be n minus 1. That goes all the way down to 1,000. All the way down. Regardless of how high this number is, I start with n minus 1, go down step by step until I have nothing. Let me swap that around a little bit so I can recognize it. Same thing, I'm just going to write it in reverse. 1,000 plus 1,000 times 1.04. Next one would be 1.04 squared, all the way to 1,000, 1.04 to the n minus 1. What kind of sequence of numbers do I have there? Match this with A, AR, AR squared, AR to the n minus 1. So this is the sum of the geometric sequence. And I just did a formula for that. Plug it into the formula. 1,000 times 1.04 to the n minus 1 over 1.04 minus 1. Everyone happy where I'm getting this? Formula for the sum of the geometric sequence. Let's put a little n here because it depends on the number n, the number of years that I'm interested in. Plug that in and it gives me my answer.
You said that the ends would be outside of brackets.
This n goes with this guy. There's nothing outside. No. But this, there's brackets here because this 1,000 gets multiplied with this whole thing. So for example, if n is equal to 3, we got that answer in A, in part A. My amount, the total amount of money that I have at the end of 3 years, let's see if I get the same amount. 1,000, 1.04 cubed minus 1 over 1.04 minus 1. Do I get the same amount? Just check. To convince myself that this formula is correct. I should get 3121.6. I'm just doing it in a short way, skipping over, looking at every year, skipping to the one I'm looking for, target year. That was technically part C. Now I want to do the same thing, but not with 1,000, not with 4% interest, in general. So you can give me any amount, any interest rate, any length of time, and I can plug it into my formula. What does that formula look like? Same argument, same thing, a little more general.